Okay, so I am going to go over in this video, I'm going to go over exam 1. I'm going to do all the problems. That's the plan, and this is the last lecture of the week. Okay, so problem 1 was to compute the area between two curves. One was y equals x squared, the other was y equals 4x minus x squared. And here, the graph looks like y equal x squared looks like this, and y equals 4x minus x squared looks like this. And we're supposed to compute it between in this bounded region here. So what is that? That's the case where x squared is equal to 4x minus x squared. So that tells me that 2x squared minus 4x equals 0. So it becomes x squared minus 2x equals 0 if we divide by 2. So it's, oops, that's not good. Did I do this right? Yeah, it's right. It's x times x minus 2 equals 0. So x equals 0 and x equals 2. This is the 0.24. So we're going to compute the area. So we take a little vertical strip, and that has the length of that vertical strip is given by the top curve minus the bottom curve. So it's the integral from x going from 0 to 2, because this is the x-axis here, and it's given by 4x minus x squared. That's the first curve, the top curve, minus the x squared. That's the bottom curve, dx. So the integral from 0 to 2 of 4x minus 2x squared dx. This is easily computed. It's given by 2x squared minus 2/3 x cubed from 0 to 2. You stick in 2, you're going to get 2 times 4 minus 2/3 times 8. And if you stick in 0, you get nothing. So this is minus 0. And if you do the computation, you should get 8/3. So that's the answer to the first question. It's 8/3. I'll turn to problem 2 now. So in that case, the two curves are y equals x squared and y equals x to the 4th. We look at the region bounded by both of them. So y equals x squared is higher than y equals x to the 4th on the region in question. So y equals x to the 4th is there, and we're interested in between 0 and 1. So this point is the point 1, 1. Okay, so what are we doing? Well, we're going to take this strip and we're going to rotate it around to get a washer. And we have a big radius and we have a small radius. So the volume of the washer of thickness delta x is given by pi times the big radius squared minus pi times the little radius squared. That's the area times delta x. So what is that? That's pi times x squared squared minus pi times x to the 4th squared times delta x. Okay, so that tells us what the integrand has to be. It's the integral from 0 to 1. I'll bring the pi out. It's x to the 4th. X squared squared is x to the 4th minus x to the 4th squared, which is x to the 8th. The exponents multiply. Basic algebra. Many people got that wrong, believe it or not. Many people wrote x to the 6th over there. That is not correct. In any case, so what does this give us? This gives us pi times x to the 5th over 5 minus x to the 9th over 9 from 0 to 1. Evaluation at 0 does absolutely nothing. So it's pi times 1/5 minus 1/9, and that's 4 pi over 45. That's the answer. So that's the answer to the second problem. I'll now come to problem 3. That's the integral of e to the x tangent cubed of e to the x dx. It's very important when you write integrals to put the dx in. The dx is crucial. This term here, many people don't write that. That leads to mistakes, I claim. Always do it. Okay, so Let's go back. Okay, so how do we do this? I'm going to let u equal e to the x. I think I suggested that as a hint on the exam. Then du is e to the power of x dx. So this becomes, this is the e to the x dx term. So this is tangent cubed of u du. That's what ends up happening. The e to the x dx is absorbed into du. Okay, and then the best way to do this is to break off a tangent squared of u, and then there's a tangent u du left over. And I'll continue over here, I'm going to use the trig identity secant squared u minus 1 times tangent u du. And then I'm going to break it up into two integrals. It's secant squared u tangent u du minus the integral of tangent u du. Okay, so the first integral is the first of these integrals. Let's call these 1 and 2. Let's deal with 1 first. Okay, so I'm going to rewrite it as, let me do it like this. I'm going to set v equal to tangent u. So then dv is secant squared u du, and that's what we have in the integrand. So this becomes the integral of v dv, which is v squared over 2, which in terms of u plus c, which in terms of u is tangent squared u over 2 plus c. Okay, the second integral that occurs is well, let me just write the integral. So it's tangent u du, and that's given by sine of u. Let me write a minus tangent u du because we have that. Oh, minus sine of u over cosine of u du. Okay, so now if we let w equal cosine of u, then dw is equal to minus sine of u du. So actually, let's put the minus sign here inside the integrand. We're allowed to do that. So therefore, this is the integral of dw over w, which is ln absolute value w plus c. But w was cosine of u, so it's ln absolute value cosine of u plus c. Okay, so we have enough information to complete the problem. We just have to add 1 and 2 together. So let's do that here. I'm going to make some space. Okay, so the two integrations we got were 1, and then there was 2. So we have to take 1 and add 2 together. So 1 plus 2 is given by tangent squared u over 2. And then we have ln absolute value of cosine of u plus c. Okay. Now some of you, oh, that's not the answer though, right? That's actually not the answer. We have to go back and convert it back to e to the x. So let me erase more stuff. Everything has to be expressed in terms of x to do the problem. So this is tangent squared of e to the x over 2 plus ln absolute value cosine e to the x plus c. Now, some people got an answer that didn't look exactly like this. Some people in the first expression here got a secant squared e to the x over 2. That's okay because secant squared e to the x over 2 and tangent squared e to the x over 2 differ by a constant, and the constant can be absorbed in the last constant. So that's going to be the same thing. Some people put a secant e to the x here and put a minus sign in front of the ln. That's the same thing as well by a well-known fact about logarithms. So, but this is the answer I got, and your answer should be either that or one of the variants that I just mentioned. Okay. Okay, so let's go to number 4, which is the integral of the square root of x squared minus 1 dx over x. So I'm going to let x is a trig substitution. Let x be secant of theta. So dx is secant theta times tangent theta d theta. I'm going to put my right triangle in over here right now just for later. So secant of theta is hypotenuse over adjacent, so that would be x over 1. And this would be the square root of x squared minus 1. Okay, so that's by the Pythagorean theorem. Okay, so now let me do the substitution. So what do you get? You get the square root of secant squared, secant squared theta minus 1 times dx, which is secant theta tangent theta, over secant of theta, and there's a d theta here. So now this becomes the integral. Secant squared theta minus 1 is tangent squared theta, so the square root of that is tangent theta times tangent secant theta times tangent theta d theta over secant of theta. The secant thetas cancel, and we're left with the integral of tangent squared of theta d theta. The easy way to do this is to apply the trig identity, because tangent squared theta is secant squared theta minus 1 d theta. And this is the integral of secant squared theta, which is tangent theta, minus the integral of 1, which is theta plus c. Now we have to go back and figure out what tangent theta is and theta is in terms of x. Well, tangent theta is opposite over adjacent, so that's the square root of x squared minus 1. Theta is given by the inverse of the secant function. Okay, so this is going to be the, and this is the, I'm sorry, this is not written correctly up there. So let me, secant inverse x is theta. So let me correct that. So this should be a secant inverse x here. So this is the answer to, oops. This will be the answer to the question. Okay, and again, there are variants of this, which I won't, some people got an arctangent there of the square, arctangent of the square root of x squared minus 1. There's a trig identity relating those two things, or an inverse trig identity, one should say. Okay, so that is that question number 4. Okay, now we go to question number 5, which is the integral of x plus 1 dx over 2x plus 1 times x minus 1. So we have to take x plus 1 over, this is going to be a partial fractions type of calculation. So this is going to be an a over 2x plus 1 plus a b over x minus 1. And then when we multiply by the large denominator on the left side, we get x plus 1 is equal to a times x minus 1 plus b times 2x plus 1. And if you take, so if we, let's work over here. If we take x equal to 1, the left side of the equation becomes 2, and the right side of the equation becomes 0 plus 3b. So 3b, yes, so 3b, so b is equal to 2/3. That's b. What about a? Well, for a, we can take x equal minus a half, because then we get on the left side 1/2, and the right side becomes a times, so minus a half minus 1 is minus 3/2. Okay, so we can solve for a, and a will be minus 1/3. Okay, so now we're ready to integrate this. This is the integral of a over 2x plus 1, so that's minus 1/3 dx over 2x plus 1 plus b, which is 2/3 dx over x minus 1. So you can do this by a substitution, or you can do it by a fudge factor method. I'll do it by the fudge factor method. So we want to get something, so let's bring the 1/3 out. We want to, it should be ln absolute value 2x plus 1 in the first case, but that's not the right factor because when we take the derivative of ln absolute value 2x plus 1, a factor of 2 comes out. So we have to fudge it by dividing by a factor of 2. That makes this minus a third a minus 1/6. Okay. The second term is going to be 2/3 ln absolute value of x minus 1, and sort of then we have to add a c, and then we're done. Okay, so that takes care of problem number 5. Okay, so so now we come to the last problem on the exam, which was called number 5 on the exam page. That was a typo. It should be called number 6. So it's the integral of x times secant squared x dx. This is probably one of the easier problems on the exam. We're going to do an integration by parts. U equal x du equals dx, dv equals secant squared x dx. So v equals tangent x. So then it's u times v, which is x tangent x, minus the integral of v du. So that's the integral of tangent x dx. Now we saw, so we can rewrite this, let me do it over here, as x tangent x plus the integral of the negative of sine x over cosine of x dx. And then you could do a u substitution. We already did this integral previously on the exam. We're going to get x tangent of x plus ln absolute value of cosine of x plus c. That's the answer to the last problem, and also the last problem on it's at the end of the exam. I still haven't gone over that extra credit problem, which only one person I think submitted an answer to. I'm going to do that, but not today. So have a good weekend.